Correct? Now I want to know the interval where the function is monotonically increasing. Now I need to differentiate both of them. Correct? So let us start with this function x minus 1 by x square. Let's find the derivative of this function. But remember, when I am finding the derivative of this function and I am trying to solve this inequality, suppose I am finding the interval in which it is monotonically increasing, I differentiate this and make it greater than 0. Whatever answer I should get, I would take only that interval which is in the interval x greater than equal to 1. Remember that what I told you, your answer must not exceed the domain of the function. So if you are solving this inequality, your answer should be only that part of the interval which is meeting this condition. Are you getting this one? So let's differentiate this. So I'll get x square minus x minus 1 2x by x to the power 4 greater than 0. So if I simplify this, what will I get? 2x minus x square by x to the power 4 should be greater than 0, right? Yes? So let's apply the Wavy curve. So 0, 2, this is always positive, right? So I can just solve this inequality. Now this is minus plus minus, correct? Yes or no? So in which interval it is always positive? 0 to 2. But remember, what is my parent condition? What is my domain? Greater than equal to 1. So which interval will I take? 1 to 2 I will take only. Correct? This is only about this function. What about this one? So let's take that as well. So d by dx of 1 minus x by x square, I think it will not take you much time to figure it out that it is x square minus 2x by x to the power 4. Correct? It's a negative of the previous function. Now if this has to be greater than 0, again by Wavy curve, plus minus plus. Correct? So which interval will you take? 2 to infinity and minus infinity to 0. Correct? But this function is valid only when x is less than equal to 1 and not belonging to 0. Correct? And not equal to 0. So which interval will I take? Minus infinity to 0. Are you getting it? I will not go for 2 to infinity because my domain of the function is less than 1, which only stops at 0. So the function is monotonically increasing in the union of these two intervals. So you say your function is monotonically increasing in the interval minus infinity to 0 union 1 to clear?
So should it be a closed interval?
Yeah, closed interval.
One to two should be a
Close that one open. Should include one also. Main also includes one.
It's 0, it's not strictly increasing. You have 0.
no, the value of the function may be 0. That is fine. Yeah, so if I put x as 1, what does happen? It becomes 1, right? Yeah, you are correct. Similarly, 0 can also be included. No, 0 will be exactly 0. You are correct. What is the interval in which the function is monotonically decreasing? What is left? Which interval is left? 0 to 1 is left. 0 to 1 is left. And 2 to infinity. Sorry?
Does it have to be decreasing in the
Yeah, because if it is not greater than, it will be less than, right?
But then like, say for example, if you increase it and what if it goes like this, then you get
I get your question.
like if it's strictly increasing, so it's like a line like this, and then so we included that interval, but then what if after that it's like this, and all this?
All those intervals will be included in that inequality sign. Whenever it is increasing, all these increasing one will be union. All the decreasing will be union. Okay. So the answer for this would be the function is increasing in the interval minus infinity to 0 union 1 to 2 and decreasing from 0 to 1 union 2 to infinity. By the way, this 1 could be included here as well, right? 1 could be included here as well, right?
Wait, then
So I don't.
sorry.
Because at 1 this function would be less than 0, right?
So yeah.
That's why it will be under both the conditions. So the idea is do not include 1 at both the places. Do not include 1 at both the places. Because 1 can fall in both the intervals. If you do one thing, if you include 1 over here and not over here, then only you can include it here and not here. Okay. But the main aim of this question was to let you know that whenever you are performing the check on the interval, where it is increasing or decreasing, keep in your mind what is the interval for which it is defined. That is the domain of the function should be kept in mind. Do not write anything. Let's say you are dealing with a log function and you get x lying between minus infinity to 2. Correct? X cannot lie between minus infinity to 0 if you are dealing with log function. So your answer will be from 0 to 2 only. Are you getting it? Because such options will be there in your option and you will end up marking it incorrectly. So be careful about your domain of the function. Now these are the type of functions that you can get in school. Let us see how JEE will frame questions on monotonicity. So we'll start with this question. Let's start with this question. Find the number of solutions of the equation 3 tan x plus x cube equal to 2 in the interval 0 to pi by 4. Find the number of solutions of the equation 3 tan x plus x cube equal to 2 in the interval 0 to pi by 4. Now you must be wondering, how is it a question based on increasing decreasing? That's how JEE will frame question. You will not even come to know that something related to calculus is to be used here. There are solutions. One way to do it is plot the graph of 3 tan x and 2 minus x cube and see where they intersect. One is that way. Another way would be the use of calculus. Anybody has any idea how to do calculus?
So you just bring
differentiate and check for the strictly increasing wherever it's not in that interval.
Okay, let's consider a function to be 3 tan x plus x cube minus 2. Okay, correct? Now if I differentiate this, I would get 3 sec square x plus 3x square, correct? Which is always a positive term. That means the function is always increasing, correct? That means it is increasing in the interval 0 to pi by 4 also. Now what is the value of the function at 0? What is the value of the function at 0? Minus 2. What is the value of the function at pi by 4? It's 3 plus pi by 4 whole cube minus 2, which is definitely some positive number, right? Correct? Now if there is a function which is always increasing, at 0 it is minus 2 and at pi by 4 it is some positive number. I don't know what is that positive number, this number, okay? So this function will cut the x-axis at how many places? Only at one place, isn't it? That means this function will be 0 only at one place and therefore this function will have only one solution. Is that okay?
Yeah.
See, how in an indirect way I connected it to solving this equation through use of monotonicity. Can I explain it again?
Yeah.
Function is always increasing. That means the function is not going to turn any way down. It's always on the rise. Correct? Now the value of the function at 0 is at minus 2. It is increasing. At pi by 4 it became some positive value. Correct? Correct? Now, in between 0 to pi by 4, it will cross 0 somewhere because it is going from minus 2 to some positive value. So it will become 0 at some value between 0 to pi by 4. Right? Now how do I know it will be only one value? Because the function is always increasing in that interval. Had there been two values, the function would have decreased also somewhere. Isn't it? How do I know this is only like this and not like this? How do I know?
Because 3x.
Because it is continuously increasing in the interval. Had it been like this, it would have increased here, decreased here, increased here. Are you getting it? But such is not the nature of the function. The nature of the function is always to increase. So it can never take a turn back. Are you getting the point? So it can only cut the x-axis at one point, which can only be possible when the graph is somewhat like this. Right? Now again, this is how JEE will frame questions. Let's take more such examples. Avnish, clear?
So when you said that the nature of the function, like what do you mean by that? Like, you're saying that the nature of the function is always increasing.
Increasing.
So like what function are you talking about?
I'm talking about this function.
So like tan x in general, right?
No. I'm talking about this entire function. I brought the 2 on the other side and made a function out of it. And I'm saying that function is always increasing. Correct?
Yeah.
The value at 0 is minus 2. The value at pi by 4 is some positive number.
Yeah.
That means the function will become 0 for a value between 0 and pi by 4. And that will only happen once. Because it is all the rise.
Yeah.
Right? So only it will cut the x-axis at one place. So this expression can be equal to 0 only for one value of x. And hence, this equal to 0 will be satisfied by only one solution. Is the idea clear? Has it given you a new perspective to take this concept? Let's take few more examples of such kind.
So how do you solve it using calculus?
Calculus only I used.
Like while like differentiating it.
I differentiated it only in this.
Yeah, it's
I differentiated it. Next problem. Let g of x be f of x plus f of 1 minus x and f double dash x is always greater than 0 for all x belonging to 0 to 1. Find the interval where g of x is monotonically increasing and monotonically decreasing. What is the answer? 0 to half and half to 1. Okay. 0 to half is decreasing and increasing. Correct. That just means the function is concave now. So this has to have a maximum value. So it will be increasing 0 to 0.5 and decreasing.
No, it will be.
Positive is concavity. Yeah, so that's the good. So good to see somebody solving it just by using geometrical interpretation and graphical interpretation. Any idea, anybody? Okay, let me first solve this in a normal mathematical way. See, what is the meaning of f double dash x greater than 0?
It's decreasing.
It means that f dash x is an increasing function, correct? Yes or no? Correct? If derivative of something is positive means f dash x is an increasing function. Correct or no? I've written f dash x, I've written f of x. F dash x is an increasing function. If f dash x is an increasing function, that is what we graphically learned as the function being concave upwards. See, when a function is like this, what is happening to the slope? Slope is constantly on the increase, right? Correct? F dash x is increasing. Then only the slope is becoming from negative all the way till positive, right? So f double dash x hence would be greater than 0, correct? So f dash x is an increasing function, that is for sure, in the interval 0 to 1, correct? Now, if I am inquiring about the nature of g of x, first of all I have to differentiate it, plain and simple. What is the derivative of g of x? F dash x. What is the derivative of this? F dash 1 minus x times minus 1, correct? Which is f dash x minus f dash 1 minus x. Now if I have to find the interval in which the function is monotonically increasing, means I have to solve this inequality, correct? That means indirectly I am saying f dash x should be greater than f dash 1 minus x, correct? Now you know your function is increasing function. So when can you have the value of f dash x greater than the value of f dash 1 minus x? When the input itself is greater than the input of this. Yes or no? The function is on the increase. So for a higher input, it will have a higher value, isn't it? So f dash x is greater than f dash 1 minus x means this input itself should be greater than this input.
So you get x.
Yes or no? That means 2x should be greater than 1. That means x should be greater than 1 by 2. That means from half to 1 the function is monotonically increasing. So can I say it will be monotonically decreasing for the interval 0 to half? Yes or no? Now Atmesh had another way of explaining it. Can you explain it on the board? Hello?
Okay, so yeah, if this is the graph, okay, f of x is equal to f of 1 minus x, and the domain is 0, 1. So this is kind of an observation that f of 0.1 will be equal to f of 0.9. F of 0.2 will be equal to f of 0.8 and so on. So there has to be a certain point about which it is kind of mirroring. So yeah, so let's just say this is that point. So yeah, this kind of gets mirrored, and that point has to be 0.5 because yeah, it has to be 0.5 because the center part of the domain. Yeah, and then since f double dash x is greater than 0 at x equal to 0.5, it has to be a minima. So the graph looks something like that. So from 0 to half it is decreasing, and from half to 1 it is increasing.
Got it? So basically, because the function g of x is the sum of f of x and f of 1 minus x, the value that you will get for 0.1 is the same that you will get for 0.9. You see that? Because 0.1 will give f.1 plus f.9, and 0.9 will give you f.9 f.1, which is adding up to the same thing. So you figured out that the function is symmetrical about x equal to 0.5, right? And you also figured out that there is a minima at 0.5, correct? So the minimum. So the function is dropping. The function is dropping like this, and then it is picking up from it. So decreasing from 0 to half and increasing from half to 1.
So like, how can you say that it's
I got the 0.5 thing, but I didn't know how to take how to decide it's decreasing or increasing.
They've given equation f double dash x is greater than 0.
Yeah, it's this double dash x, right? So that f dash x is also
I never said that. I said f dash x is increasing. F dash x is a function on its own. It is an increasing function. See, there is a misconception that I see in most of you. You feel that if a function is negative, it can never be increasing. And you are relating the increasing with the positivity of the function. No. Function can be negative and still be increasing. Function can be negative and still be increasing. Function can be negative and still be increasing. So you can have various possibilities. Don't relate it to that. Here I am saying f dash x is a function which is increasing. I never said f dash x is greater than this. Getting the point? For example, if I make a parabola like this, it is negative, but still it is increasing. Right? So don't think that f dash x. No, I'm not talking about f of x. I'm talking about f dash x being an increasing function and f dash x being a decreasing function. F dash x is increasing. I'm not saying this doesn't mean f dash x is positive. When you say this means you're saying f of x is increasing. F dash x is increasing is different from saying f of x is increasing. They're not the same things.
Yeah.
Okay. Very good. I really like this way of solving. Next question. Let g of x be f of x whole cube minus 3 f of x whole square plus 4 f of x plus 5x plus 3 sin x plus 4 cos x. Its domain is all real numbers. Prove that g of x is increasing whenever f is increasing. So only if f of x is an increasing function, g of x will also be an increasing function. Maths and chemistry are the key. Physics, it's okay. Physics and it's not like decider. Decider is maths and chemistry. So work on your chemistry. First, yes. So 1st of July would be your next phase test. It will be covering everything in class 12 done so far. Continuity, differentiability, AOD, differentiation, inverse trig, functions, everything will be 1st of July.